system, rho and phi are perpendicular to each other. Now, when we finding the position in a Cartesian coordinate system, let I consider a vector A. The vector A's position in Cartesian coordinate system is ax of A, ay of A, and az of A. Here, ax is a magnitude in x direction, ay is the magnitude in y direction, and the az is magnitude in the z direction in Cartesian coordinate system. And ax, ay, and the az are the unit vector of the respective axis, and they are showing the direction of the vector in which direction the vector A are moving and how much move. That means the magnitude of in x direction is ax, in y direction is ay, and the z direction is az. Now, when we are finding the distance or the displacement between the 2 points in the Cartesian coordinate, that is equals to x, y, z. Here the 2 point P and the point Q, point P and the point Q. This is the R1, and this one is the R2, and we move from P to Q. We move from P to Q. The distance of P to Q is equals to, that means the position, this position is x1, y1, z1, and this is the position for x2, y2, z2. When we are going to find P to Q displacement, we have differentiate x2 minus x1 ax plus y2 minus y1 ay plus z2 minus z1 az. This is the displacement in Cartesian coordinate system. Similarly, we are going to find the displacement in cylindrical coordinate system. Now today we are going to start cylindrical coordinate system. The cylindrical coordinate system has 3 variables. Now we start. The cylindrical coordinate system. This is the axis mutually perpendicular x, y, and the z. For the cylindrical coordinate, we draw this is a represent a curved surface of the cylinder, and its angle is phi, and this is a radius of a curved surface. This is a z axis which is parallel to this z axis, and now we draw here. This is a parallel to y axis, and this one is parallel to x axis. Okay. Now this is a cylindrical coordinate system. Here, this is the direction for arrow. This is the direction for a, phi, and this is the direction for a, z. That means with the help of the ax, a phi, and the az, we find the direction in which direction the particles are moving. So here 3 components are there: az, arrow a phi az, and arrow a phi az are perpendicular to each other. Let me consider a point here P. Consider a point P. Its value is, that is, this one is the phi. This is the parallel to this row. Its value is, this is a phi, this is a row, and this one is a z. Now, how we write the position of P in cylindrical coordinate systems? The P is a position in cylindrical coordinate system is P is equals to arrow plus a phi plus az. Here A row, capital A row represents a vector A whose magnitude in row direction is A row. In vector A phi represents magnitude of vector A in A phi direction, and in the case of Z direction, AZ is a magnitude of vector A in Z direction. This is a position vector by which we write in the cylindrical coordinate system. Okay. Now we are going to find the components. How we find the components? A row, A phi, AZ. The relation between now we are going to find the relation between A row, A phi, AZ. That means the relation between Cartesian coordinate to cylindrical coordinate system. Now Cartesian coordinate to cylindrical coordinate system relation. Do you draw this figure? Here x-axis, y-axis, z-axis. This is a Cartesian coordinate system. In the Cartesian coordinate system, in x direction the unit vector is ax, in y direction the unit vector is ay, and in the z direction the unit vector is az. Okay, this is the point I am considering. This one is a point that is lie on this place. And draw here. This is a R. Here is a point P. Here is a point P. This one is a row, and this is a phi. The component unit vector for the row is equals to here, that's represented by A row. The phi is equals to A phi, and the z is Az. Okay, now I'm write P here. Now I draw a parallel line with x-axis, that is a distance. This is the x dash. I am considering this is the x dash. From P to x dash is parallel to 0 to x-axis. Due to that, this angle and this angle is equal due to the corresponding angles. Now, here this is the ax. Both are parallel. Due to that, this is also a ax. Similarly, now I am drawing the parallel line with y-axis. That is a a1. Okay, this is a a1. Now we know that this one is a x-axis and this one is a y-axis. X and y-axis are perpendicular to each other. X-axis and the y-axis are perpendicular to each other. That's why the angle, this one, the angle in between A row to AY is 90 degree minus theta. The angle here 90 degree minus phi. Now we also know that in the cylindrical coordinate system, A row and the A row and the A phi. This is a phi. That means I will redraw this figure. This is a AY. This is a A phi. This one is a A row. This is the angle 90 degree minus phi. Now what is the angle of this? A row and A phi are perpendicular to each other. That means A row and A phi are perpendicular to each other. Then what is the value of this one is 90 minus this angle, and the angle is 90 degree minus phi, and that is equals to phi. That's why I write here the angle in between A row to A phi is phi. Now resolve with the help of the vector. Now here, when A row moves towards AX, its components become A row cos phi, and when this A row moves towards AY, then its component becomes rho of sin phi. Similarly, when we resolve a phi, that means this is a phi, this is a phi, and this is a x dash, and this is a minus x dash. So when we resolve this a phi in y axis, we get a phi in y axis, we get cos phi a phi, and when we resolve in this direction, that means this is a x and this is a minus x, that's why its value comes minus of sin phi a phi. That means its value is in this direction is minus of sin phi a phi. We know that the rho and the phi are lie in between x-axis and the y-axis. That's why we have the two component for the rho and the two component for the phi. Now I'm writing what is the relation of the Cartesian to cylindrical. That is this one is a ax. Here ax is equals to, there are the two components are there. First component is phi and second component is a rho. That's why here cos phi a rho plus second component for parallel this one. The parallel this side is x-axis parallel is minus sin phi a phi, and right here this is a x, this is a minus x-axis, and the phi's component is minus a phi. That's why its value is minus of sin phi a phi. Now it is equals to cos phi a rho minus sin phi a phi. I think got it. How can I find the value of the ax? Now similarly we are going to find the value of the ay. Now this is the arrow, it's moved towards this side, ay side. The unit vector ay is equals to this one is its value is arrow sin phi. That means sin phi arrow, and the second one is phi. The phi's value in this y axis, this value is plus the cos phi a phi. The cos phi a phi. That means there are the two components of the Cartesian coordinate ax and ay, which is equal to in the cylindrical coordinate is cos phi a rho minus sin phi a phi. In the ay case, sin phi a rho plus cos phi a phi. Okay. Now for the z, az is equals to, in the case of Cartesian coordinate, z represents this one, and in the case of the cylindrical coordinate, z also represents this one. That means both, this is a az for the Cartesian coordinate and this one is the az for the cylindrical coordinate. Both are parallel to each other. That's why both are parallel to each other. That means the unit vector in cylindrical coordinate and Cartesian coordinates are equal. That means az is equals to az. Now form the matrix, form the relation of Cartesian to cylindrical in matrix form. I think you have any doubt? No, sir. Clear? Yes. Matrix with Cartesian to cylindrical coordinate. Here I have the component ix, ax, ay, and the az, and here the components are for the Cartesian and the cylindrical is a rho, a phi, and az. For the ax, x for the ax, x cos phi minus sin phi. That's why I'm right here. Cos phi minus sin phi. And what is the value of the z here? 0. That's why I'm right here. 0. For the ay's value is sin phi and cos phi. I'm right here. Sin phi, cos phi, and what is the value of the ay in?
0.
Z 0. Now here az is equal to az. That means for ax 0, for ay 0, and the az is 1. Okay. So this is a metric relation between Cartesian to cylindrical. Now we are going to find the relation between cylindrical to Cartesian. There, now find relation between cylindrical to Cartesian system. Now here I am write it is a arrow, a phi and az, and transpose this one, that is the cos phi minus of sin phi 0, sin phi cos phi 0, 0, 0, 1, and the transpose of this matrix. And the here values come ax, ay, and az. This is the ax, ay, and the az. Now, how we can find the relation between arrow to az? The relations from arrow to az is equal to
Why we take transpose?
why we take transpose. When yes, madam. When you move this matrix to in this direction, that means its value will change. That is, its matrix is changed and comes in a transformation, and the row becomes a column and column becomes a row. That's why I am transforming this. Okay. Now when we transposing this one, that means they comes like that, cos phi minus of sin phi 0, sin phi cos phi 0, and 0, 0, 1. Now with the help of this matrix, we are going to find arrow, a phi, az in terms of ax, ay, and the az. Now arrow is equals to cos phi ax plus sin phi ay. Similarly, we find a phi is equals to minus of sin phi ay plus cos phi ay, and here az is equals to az. The alternate method is also there, by which we are finding without using this matrix, and we are finding the value of the arrow in terms of the ax and ay. The alternate method is vector resolution. Now, how we resolve the vector and how we find the value of the arrow in terms of the ax and ay, the alternate method is by which we finding the value of the ax and the ay in terms